How's this different than the example we did above? Who said that? There's a 3. I mean, other numbers are different too. But if your A value is anything other than 1, it's going to make it slightly more complicated. Not terrible, but slightly. You're still going to move the constant away. So we're still going to start by adding 2. That's not changing. But do you see in your vertex formula, I'll rewrite it so it's all in the same. Do you see in the vertex format how this A is outside in front of a set of parentheses? Okay? To kind of morph into that, we need to factor out any A value if it exists. So this being 3, we need to just factor out the 3. I know that there's a GCF of 3x, but we don't bring out the x, just the 3, just the A number. So I'm going to pull out the 3, and that's going to change this into x squared plus 4x. And then I'm going to leave a little space in there, because this is now where I have to complete that trinomial. Jake W., any idea what I would add in here to complete the trinomial? 4. Anybody disagree? You sure? How'd you get that, Jake? Perfect. He took half of b, got 2, and squared it. He gets 4. Now, here's where this differs. Another place where it differs. We added a 4 in a set of parentheses that is eventually going to be multiplied by 3. So how much did we really add to the right-hand side? 12. So we have to add 12 to the left-hand side to keep all things equal. Let me re-explain that. We added 4 to complete a trinomial that was in a set of parentheses that is going to be multiplied by 3, or that is multiplied by 3. So by adding 4 that's being multiplied by 3, we actually added 12 to the right. So we have to add 12 to the left to keep all things equal. So we get y plus 14 equals 3, and who can factor that for me? What is this? What's squared? X plus 2. Braden, share with everybody how you're so quick at that. Perfect. Whatever half of b was, that's what that is going to become. Now, you could do it the long way, and you could sort of guess and check x and x, 2 and 2, plus and plus. Oh, look, it's the same thing twice, x plus 2 squared. You could do that. The shortcut is it's just half of that middle term. That's what it should factor into if you've done all things correct. And then we subtract over 14, and we're done. What, Maggie, is my vertex? -2, -14. Good. Opposite of the h that she thinks she sees in the -14. Any questions? Okay. We'll come back. B is just more of the same. Exercise 5 here, and let me tell you what the point of all of this is. It's telling us to use our negative b over 2a formula to find the turning points. Ideally, all I would do here is I'd use the negative b over 2a method to get the vertex, and I would also use the completing of the square method to get the vertex, and I would just be showing you that they're going to give you the same thing both times. Does that make sense? So we're let's skip that for now, because I would just, what we did yesterday with finding the vertex, negative b over 2a, is the same thing that we're doing today. It's just I'm exposing you to this newer format and more useful format that you need to get comfortable with, okay? And you need to get comfortable with it maybe for reasons like number 4. So you're often going to be given things in vertex format. So just looking at this function, what is the vertex? Jake O. 617, great. So if I were to do a quick sketch of that, 617 would be somewhere up here. 617. Brock, what is my A value? My A value? Y equals A, x minus h squared plus k. Look again. Negative 1/2. And given that it's negative, what does that tell you about your parabola? Opens down. So here's my vertex, and it opens down. Perfect. So now let's read the question. Should be pretty easy once you have a sketch of this. When is this strictly decreasing? So think back to your interval notation. From when to when, if you look along here, it's decreasing. When does it start to decrease? Ever? From 6 and beyond, right? Not technically right at 6. So from an interval notation, we'd say it's decreasing from 6 to infinity. Well, which one of these says 6 to infinity? 1, greater than 6. Okay? Now, of course, you could just type that into your calculator and get that sketch from your calculator, but if you're not great at Windows and you don't know how to see the parabola on your calculator, then you could definitely sketch by hand. Okay? Any questions on that? Okay. 15, what is the x-coordinate of the turning point? You could do this either way. If you prefer the negative b over 2a method, you could do it that way. If you prefer completing the square and turning the format into HK format, then do it that way. Mitch, what do you think is easier in this particular problem? Right. With an A of 5, completing the square is going to be a little bit difficult because once you add your 3 over, you have to divide out the 5. But when you take a 27 and divide out a 5, that's going to leave you with a fraction decimal, right? So it's going to be pretty ugly if you try to complete the square. So my recommendation on this one would just be to do negative b over 2 times your A value of 5, so 10. And which one's negative 27 divided by 10? 1. Hopefully you don't reach for your calculators on that one. Right? When you divide by 10, you just move the decimal place over once. Okay. 16, we have to rewrite this in HK formula. There's no way around it. Actually, there is a way around it. If you really were terrible at this and you were on the regions, what could you do instead of subtracting the 55 over, dividing the 3 out, instead of doing the process, how could you, given that it's multiple choice, find a way around that? Right, you could square this out, multiply by 3, add 2, simplify, 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 and see which one matches. That will work. It's just you're not going to have enough time in this class to do that. Okay, so you obviously, and when it's open response, that's not an option. So, first step is to subtract that 55 over. Let's do that. So it'll be y minus 55 equals 3x squared minus 24x. Josh, what's my next step? Say it again. Not yet. I'm going to write the steps on the side of your notes so that you have them. Subtract the constant over, or add, I guess. It doesn't have to be subtract. Add or subtract the constant. Look back at that example, Josh, on the front side, bottom left. Once we moved the constant over, what did we do next? Because there's a coefficient. You factor it out. Very good. So 2 is factor out A. Just the A number. So y minus 55 equals 3 times x squared minus 8x. Step 3. How would you describe or tell me what to do for step 3, Kelly? We're not ready to do that yet. We have to figure out we actually have to complete the square. How do you figure out what to add in here to complete the square? Right. We take half of b and then square it. Correct. And add to complete the square. And we have to counter that on the other side, correct? You have to counter that on other side. So Kelly said to add 16 in here. What am I going to add on the other side? 48. Val, do you know where they're getting that from? Perfect. And that's 48. Good. So you added 16, it looks like, but you really added 48. So you add 48 to the left-hand side. So you get y minus 7 equals 3. And now you factor this. You had to complete the square before you factor it. So factor the trinomial to x minus 4 squared. And then get y all by itself. Get y by itself. Add the 7 over. Y equals 3 times x minus 4 squared plus 7. Answer is 4. Mike, what's the vertex of our parabola? 4, 7, great. A value is a 3, so it opens up. We're all good there? Nice. Okay. What I want you to do for 21 is just listen. Okay? If I asked you to define a parabola, if I asked you to define a parabola, what would you tell me? What is a parabola? Come on, Gracie, what's a parabola? I knew it. Everyone would just like kind of trace it. Like it's something that goes like this, right? That's a tough definition. Something that you've never known about a parabola. A parabola is the set of all points that are the same distance away from a fixed line. So like, let me give you a line like this. This would be my fixed line and a fixed point. Okay? If I asked you to find a point that's equidistant from the line and from the point, where would be the first place you'd all draw a point? That's going to be the same distance away from this point as it is from this line. Go do it, Andy. Go up, grab a marker, draw, just put a point that's the same distance away from the point as it is from the line. That point that you just drew, stay up there, move to the side. How far, what do you guys think? Is that red dot closer to the line than it is to the point? Yes. I want you to draw a dot that's the same distance away from the point as it is from the line. Yes. Okay, get rid of that other one. So, all of you, there's a point. Let's pretend that's 2 units away and 2 units away. Okay? It's halfway in between. The next one would be, and there's an infinite number of possibilities, would be something like here. That might be, well, maybe it's a little lower. 3 units away and 3 units away. So that those are the same distance. And then if you go out a little further, here's something that's maybe 4 units away and 4 units away. Do you see? And what's going to happen is all those points are going to be on here, and the same is going to be true going this way. Take any point on that parabola, and if it's 5 units away from the point, it's 5 units away from the fixed line. So we're going to learn all tomorrow about the fixed point, which is called a focus, and a fixed line that's called a directrix. And this concept has been on every single regents that we've seen so far. Focus, directrix. So just a brief introduction. It's not on the homework.
What's the answer to this question?
I have to do it out. I would not be able to do this by hand. What do you think it is?
One.
Well, I will tell you this.